Right now, at this exact second, 100 million barrels of oil are being burned somewhere on this planet, every single day.
That is 42 billion liters every single day, enough to fill 17,000 Olympic swimming pools before breakfast.
And it all begins with something most people have never actually seen. Black, viscous, smelling of ancient earth, crude oil.
This liquid has been forming underground for 300 million years. You are about to watch what happens to it in the next 48 hours.
Here is the part nobody tells you. Crude oil is made of dead things. Specifically, tiny marine organisms that lived when dinosaurs did not yet exist.
When they died, they sank, layer by layer, for millions of years, buried under sediment, compressed, heated, chemically transformed,
Heat, pressure, 300 million years. And those organisms became something completely unrecognizable. The black gold the modern world runs on. The oil does not just sit there, it migrates, through porous rock, upward, until something traps it. A dome of impermeable rock, a reservoir. Some reservoirs hold billions of barrels. The Ghawar field in Saudi Arabia alone contains more oil than the entire United States has ever produced. One field, August 27, 1859, Titusville, Pennsylvania. A former railroad conductor named Edwin Drake drilled 69 feet into the earth, and the modern world began. Finding these reservoirs requires seismic surveys. You send sound waves into the earth. You measure the echoes. You read the data. You drill. Within 2 years, over 1,000 oil wells were drilled in that one valley. Within 10 years, the oil industry had fundamentally reorganized how civilization worked. John D. Rockefeller saw it. He moved in. By 1880, Standard Oil controlled 90% of all oil in the United States. 90%. But here is what made oil truly unstoppable. In 1885, Carl Benz built the first gasoline-powered automobile. Suddenly, crude oil had a customer that would never stop buying. Today, 1.5 billion cars, trucks, and motorcycles burn petroleum fuel on this planet every single day, all of them tracing back to that one well in Pennsylvania. When crude oil comes out of the ground, it is useless. You cannot burn it in an engine. You cannot use it directly. It has to be transformed first. So it gets loaded onto tanker ships, the largest ships ever built. Some carry 2 million barrels, the size of 4 city blocks floating on the ocean. These ships travel the same routes every week, the Strait of Hormuz. 18 million barrels per day flows through that one narrow channel. If it closes, the world stops. The oil arrives. The refinery receives it. And now the process begins that most people have never seen and never thought about, even once. A modern refinery is not a factory. It is a city. Some cover 25 square kilometers. They operate every hour of every day of every year, without stopping.
First step, the crude gets desalted, because seawater travels with the oil, and salt would destroy the equipment in hours.
Then, the heated crude hits the furnace. 400 degrees Celsius. The molecules begin to break apart. The transformation begins.
The superheated crude enters the distillation tower, 60 meters tall, and here, physics does something beautiful. Different molecules separate by boiling point.
Think of it like this. The tower is a giant sorting machine. The heaviest molecules sink. The lightest rise. Every molecule finds its place, automatically. At the very bottom, bitumen. The thick black material we pave roads with. The road under every car on Earth. It starts here.
Higher up, diesel, drawn off between 200 and 350 degrees. The fuel that powers every ship, every truck, every train, every agricultural machine on Earth. Higher still, kerosene, the fraction that powers every commercial aircraft in the sky. Right now as you watch this, 50,000 flights are airborne, all on kerosene. And near the top, petrol, gasoline, the fraction the world wants most. Lighter molecules, lower boiling point, rising almost to the ceiling of the tower. At the very top, gases, propane, butane, methane, the cooking gas in billions of kitchens across the developing world, the heating fuel keeping people alive through winter. But here is the problem. Crude oil naturally gives you more diesel and heavy oil than petrol. And the world wants petrol. So refineries had to invent a solution.
They called it cracking. Literally, breaking large molecules into smaller ones, taking the things nobody wants and turning them into the things everyone needs.
The machine that does this, the fluid catalytic cracker, is the most profitable single piece of industrial equipment ever built, by a significant margin.
Here is how it works. Heavy oil enters a riser reactor at 500 degrees, mixed with hot catalyst powder. In 3 seconds, the large molecules shatter. The catalyst gets separated, cleaned, heated again, and recycled thousands of times a day. The same catalyst particles doing the same work, over and over. The output? Petrol. Far more petrol than distillation alone could ever produce. The FCC is why modern refineries are so much more efficient than those of 50 years ago. But cracked petrol and diesel are not clean yet. They contain sulfur. And when sulfur burns, it becomes sulfur dioxide. Acid rain, lung disease, environmental damage. So refineries run the fuel through hydrotreating. They add hydrogen under pressure. The hydrogen reacts with sulfur and removes it completely from the fuel. Modern regulations require ultra-low sulfur fuel, less than 10 parts per million. Refineries hit that target every single batch, measured to the molecule. Then comes the octane question. That number on the fuel pump, 91, 95, 98, it is not marketing. It is the measure of whether your engine actually works properly. Low octane in a high compression engine causes knock, pre-detonation. The fuel explodes before the piston reaches the right position. It sounds like a tick. It destroys engines. To raise octane, refineries use catalytic reforming. They take low-octane naphtha and rearrange its molecular structure. Same atoms, completely different performance. The result is reformate. High octane, clear, performing exactly as the engine needs. One of the most carefully engineered liquids in the world. Let us talk about what is actually in a barrel of crude oil. 1 barrel, 159 liters. Here is what the world gets from it. 44% becomes petrol, 29% becomes diesel, 9% becomes jet fuel, 8% becomes fuel oil, and 10% becomes something else entirely. That other 10%, petrochemicals. The invisible fraction, the one that makes plastics, medicines, fertilizers, cosmetics, and synthetic clothing. Everything you touch that is not metal or wood. This means eliminating oil is not just about electric cars. The petrochemical challenge is completely separate, harder, and almost nobody talks about it.
Now, the scale. There are 700 refineries operating on this planet right now, processing, continuously, never stopping.
The largest, Jamnagar in India, processing 1.2 million barrels per day, every day. One refinery producing more refined fuel than entire countries consume. The control room of a major refinery monitors 12,000 individual data points simultaneously. Temperature, pressure, flow rate, composition, real time, all of it. A pressure excursion in one unit can cascade through 15 connected units within minutes. The system is so interconnected, one error can shut down the entire refinery. Every single substance in a refinery is either flammable, toxic, high pressure, or all three simultaneously. Safety at these facilities is not protocol, it is survival. Those flames burning at the top of the flare stack, that is not waste. That is deliberate, controlled combustion of gases that cannot be stored or captured, a safety valve. Modern refineries have 5 independent emergency shutdown systems. Any single one can halt the entire operation in less than 15 seconds. 15 seconds. Now the environmental question. And I am going to give you the honest answer, not the industry answer, and not the activist answer. Both. Refining crude oil emits about 180 million metric tons of CO2 per year globally. That sounds large, and it is. But it is 5% of total oil-related emissions. 95% of oil's climate impact comes from combustion, from the engines, not the refineries. The real problem is not where the fuel is made, it is where it is burned. But refineries are not clean. Volatile organic compound emissions, particulate matter, local water contamination from older facilities. These are real costs. Real people pay them. Modern refineries are between 40 and 60% cleaner than those built in 1970. The trajectory is the right direction. The pace is the honest debate.
Now, the future. 3 possible paths. Each refinery on Earth is currently choosing which road to walk, and the choice will define the next 50 years.
Path 1, fossil continuation. The refineries keep processing crude. Electric vehicles displace combustion slowly. Demand peaks, then declines. The industry shrinks, but does not disappear. Path 2. Biofuel integration. The same refinery infrastructure, but processing plant oils, algae, and agricultural waste alongside crude oil. The factory stays, the feedstock changes. Path 3. Hydrogen. Several refineries are already converting, using the same catalytic chemistry, the same high-temperature vessels, but producing clean hydrogen instead of plastic to fuel. Already operating at pilot scale. Waste plastic enters a pyrolysis chamber at 500 degrees. Diesel and naphtha come out the other side. Carbon capture is being retrofitted to several refineries. CO2 captured from the process is compressed and injected underground. The same geology that gave us the oil, storing what we took from it.
Let us walk through it one final time. The complete journey. From 300 million years underground to the pump that is 3 minutes from your house. 300 million years of chemistry. One drilling rig, one supertanker, one receiving terminal, one set of storage tanks. The crude waits. It gets desalted, the salt removed, the water separated, the first impurities stripped before the transformation begins. Clean crude ready for the furnace.
The furnace at 400 degrees, then the 60-meter tower, the fractions separating by boiling point. 5 different products flowing from 5 different heights, simultaneously.
The heavy fractions go to cracking, large molecules broken into smaller ones. More petrol from the same barrel, the yield rising, the waste shrinking.
The sulfur gets removed, the octane gets raised, the cetane and diesel gets optimized. Every parameter tuned to specification before a single drop leaves the site.
Then blending. Streams from multiple units mixed in precise proportion to hit the exact specification the fuel pump will declare. Grade 91, grade 95, grade 98. Every batch perfect.
Additives go in last. Engine cleaners, corrosion inhibitors, antioxidants, anti-foaming agents. The fuel is now more sophisticated than most people imagine possible.
The finished petrol flows to storage. Underground tanks, each holding millions of liters. Waiting for the trucks. Waiting for the pipelines. Waiting for you.
The pipeline moves it at walking pace, around 5 kilometers per hour, but through pipes hundreds of kilometers long, continuously, day and night. The product arrives.
The tanker truck takes it the last 100 kilometers. Road tank, compartmentalized, precisely metered, temperature monitored, from pipeline to petrol station in 4 hours.
The underground tanks at your petrol station hold between 50 and 100,000 liters, replaced completely every 3 to 7 days. The supply chain runs tight.
And then the moment the pump handle clicks, petrol flows. A 300 million year journey ends in 7 seconds of filling a tank. That is not ordinary, that is extraordinary.
Here is the honest truth. The refining industry is extraordinary. It is also a system built for a world that may need a different energy future. Both things are true.
The people who designed and built these systems solve problems of extraordinary difficulty. The chemistry, the engineering, the scale, genuinely brilliant and genuinely consequential.
The same engineering intelligence that built these refineries is already working on what comes next. Hydrogen, biofuels, carbon capture. The problem solving does not stop. Every technology in this video, fractional distillation, catalytic cracking, hydrotreating, was invented by someone who looked at the problem and refused to accept it was unsolvable. The world uses oil at a rate that was considered impossible 100 years ago, and the system that makes it usable runs 24 hours a day without most people knowing it exists. The next time you drive past a refinery, those towers, those flames, that steam, that is not ugly. That is 300 million years of chemistry being made useful in 48 hours.
44% petrol, 29% diesel, 9% jet fuel, 8% heating oil, 10% the material of modern civilization.
In 10 years, the ocean floor will be fully mapped. In 20, the energy transition will have accelerated. In 50, we will know which path the industry chose. We are watching it choose now. Every gallon of fuel that has moved a person somewhere. Every flight that connected 2 people who would never otherwise have met. Every harvest delivered. This industry made all of it possible, and every consequence of burning it. Every degree of temperature rise. Every part per million of CO2 in the atmosphere. This industry made all of that possible too.
Both things are true simultaneously. The industry enabled civilization as we know it, and the civilization it enabled now faces consequences it cannot ignore. Both true.
The chemistry in a refinery is extraordinary. The engineering is extraordinary. The scale is extraordinary. And the question of what we do with all of it is the most important question of the century. Crude oil to petrol, 300 million years compressed into 48 hours. Ancient organisms to modern motion, the most extraordinary supply chain in human history.
It happens in refineries you have probably driven past without thinking, in ships you have never seen, through pipelines buried beneath your feet. Right now,
Every vehicle on every road, every flight in every sky, every ship on every ocean, all of it connected to what happens inside those towers. Right now, continuously. And somewhere underground right now, the next reservoir is being drilled. The next 300 million year deposit about to be released. The machine keeps running. Until the day it does not. Until the demand goes another direction. Until the chemistry is applied to different feedstocks. Until the towers run on something the ancient ocean did not make.
the question is not whether the industry changes, it already is changing. The question is whether we understand it well enough to change it intelligently. You do now. 300 million years of geology, 48 hours of engineering, 1 drop of petrol, and a world that moves.
That drop fuels something, somewhere, right now, and the chemistry that made it possible is one of the most sophisticated industrial achievements in all of human history. You will never look at a fuel pump the same way, or a tanker ship, or a refinery tower burning orange against the night sky. You know what is happening now.
Black gold. 300 million years, 48 hours, and the world moves. If this changed how you see it, subscribe. We will be back.